All right, here we go. Topic 4, functions, domain, and range. So first thing we want to do is remind ourselves what a function is. So a function is a relation from one set, normally of numbers, that's how we've seen it, but it doesn't have to be, from one set that we call the domain, that's kind of the starting place, to another set that we call the range. That's kind of like the landing place. So we take things in the domain and assign them a value in the range. And there's one more rule. Each input, so things from the domain, can what is assigned to only one output. Only one output. Sometimes I think of that rule as no cheating x's. Okay, we talked about this at the beginning of the year with like a vending machine. So if you press a button on a vending machine, you should know what it's going to give you out. Like you press the button to get Doritos or something like that. You shouldn't press one button and have it be possible to give you like two different things. Like press one button and it might give you a Coke or it might give you a Dr. Pepper, right? If you press a button, you should know what it's giving, like what it's going to spit out at you. So that's our rule. So here's an example over here. Let's look at an example. Okay, so we can write functions in a bunch of different ways. So this example we have written first as ordered pairs. So whenever we have an ordered pair, it's always x and then y. So we're saying we take 3, that's the x, and it's paired with 2 from the y group. 4 is paired with 0 is a y. The x5 is paired with 0 also, that's okay. And the x negative 1 is paired with 4. Okay, so this is an example because if we look at the x's, see the x's are 3, 4, 5, and negative 1. So we'll never use the same x twice, okay? So let's also write this as a mapping. So the mapping is going to say, well, look here, we paired up here, we paired 3 with 2. So that means 3 should go to 2. And then we paired 4 with 0, so 4 should go to 0. We paired 5 with 0, so 5 should also go to 0. And then negative 1 was paired with 4. So our mapping would look like this. It tells us the x number and what it goes to for the y number. Okay, so one way to look at it is as a mapping. We can also look at it as a table. So here are x numbers and our y numbers, x on top, y on bottom. So this is our domain, x's, and range, the y's, like the landing places. But you can tell this isn't totally filled in, so let's fill this in. 3 is supposed to be paired with 2, so there should be a 2 right here. So we already have 5 paired with 0, but we also had 4 paired with 0, so we need to put the x4 paired with 0, and then negative 1 was paired with 4. So that's how we could fill in that table. Okay, and then as a graph, we can also put these on a graph. So the ordered pair 3, 2 is 3 to the right, because these are x's and these are y's. So x goes side to side. So we have to go over 3, up 2. So here's the point 3, 2. 4, 0 is over 4, and then we don't have to go up or down at all. 5, 0 is right here. And negative 1, 4 is all the way up here. Here's negative 1, 4. So there's all 4 of our little, of our points that we've assigned. Okay? And one thing we talked about was that vertical line test. So if you look at lines up and down, like if you were to take your pencil across the screen straight up and down, it should never hit 2 points at the same time. And this one doesn't. See, like it's only going to hit 1 there, 1 here, 1, and 1. So this passes the vertical line test to be a function. Cool. That makes us happy. Okay, so there's an example of a function. Let's look at an example of a relation or like an assignment that doesn't pass the function rule, or it's not a function. So here's a non-example. Here are the ordered pairs. Negative 3, 2, 4, negative 1, negative 3, 5, and 2, 5. So the problem comes right here. See how there's negative 3 here twice? So we're saying we have a rule that sends negative 3 to 2, but we also have a rule that sends negative 3 to 5. And that's not good. So right here, negative 3 is like a cheating x. Bad. So it's not a function. cry. Okay, but we can still put in this mapping, and we'll see how it looks for it to not be a function in different ways. So -3 is mapped to 2 first. We got that one. 4 is mapped to -1. Check. -3 is also mapped to 5. So, and 2 is also mapped to 5. So the problem is not, you can see how -3 and 2 are both pointing to 5. That's okay, because you can have 2 buttons on a vending machine that both spit you out Dr. Pepper. That's okay. The problem that we have is with this -3 being mapped to 2 and the -3 being mapped to 5. So -3 right here on the x side was used twice, and that makes it not a function, because if we input -3, we're not sure what it could spit out. It could spit out 2 or 5, and we want to be sure that we know what it's going to spit out. So we'll finish our table. -3 goes to 2, 4 goes to -1, -3 also goes to 5, and 2 also goes to 5. So our problem here with the table is this, -3 being paired with 2 and -3 being paired with 5. Okay, and then we can put it in a graph and see what that looks like. Oh, I don't want the highlighter anymore. So let's see, we have the point -3, 2, so we have to go left 3, up 2. Here's -3, 2. 4, -1 is down here. I didn't make a mark for -1. It's right there. -3, 5 is 1, 2, 3, 4. Oh my gosh, it's way up here. That's -3, 5. Trust me. And let's see. We also have 2, 5. 2, 5 is way up here. Let's say 5 is right there. So the problem with this, you can see we talked about that vertical line test on the other one. Look right here. You're out. -3, 5 and -3, 2 should be straight up and down from each other. So this fails the vertical line test. Mr. Hogan just popped in and yelled at me, if you heard that. Fails the vertical line test. Psh, no one likes failing a test, so that's not a function. Nice. Okay, cool. So there's non-example. We just have a few more. So you'll also talk about domain and range. So remember, domain is x's, that's like left and right, and range is y's, so that's up and down. I'm going to make a note of that. So this is domain is left, right, and range is up, down. Okay, so if we want to write our domain down, let's look at domain, that's left, right. So we need to look at each of these dots and see how far left or right are there. We don't care how far up and down they are right now. We just care left and right. So if we look from the left, nothing's over here, nothing's over here. Here's our first dot. Left and right, that's at 0. So in our domain, we have 0. And then, let's see, where's the next one? Right here. And that's right 2. So that's 2. And then our next dot's right here. That's at 4. Right? Okay, so we have 4. Our next dot's right here. That's at 5. And then our last one right here is all the way over here at 7. And when we just have dots like this, so we don't have like 1, we don't have anything in between 0 and 2, we just have 0 and 2, we like to put like curly braces around it like this. And that means we just have the points 0, 2, 4, 5, and 7. Okay, let's look at the range now. Okay, range. So now we're going to look up and down. Let me clear off the stuff that I drew on here. So now for range, we're just wondering how far up and down are we. So we're going to look from the bottom to the top. So the first 2 that we have 2 of them right here that are they're down 7. So in the range, we're going to have -7. You could write it twice, or you could just write it once. That's okay. Okay, our next one, if we're looking up, the next one is right here. That's at down 2, so we have -2. Okay, and then there's nothing for a long time. Here's our next one. That's up at 5. And then our last one is right up here at 7. Nice. So that's our domain and range. All right, one more of these. Let's see. Find the domain and range. So this one is a little bit different because you can see it like is a curve. It's connected, so we call it. It's like a smooth curve. So we get everything in here. So it's going to be a little bit different than the last one. Let's look at the domain. Domain is left to right, so we're just wondering what x numbers is there picture for. Like there's no picture over here. It starts right here and then it ends right here. So there's only picture in between here and here, side to side. Okay, so how we would write that, but there's picture all the way in there, so that's from -3 less than or equal to. Domain, remember, is x's, so I put x in the middle. So this is from -3 up to 2. And these were closed circles, so we make that less than or equal to, less than or equal to. All right, that's the domain. Let's look at the range. I'm going to erase this. Range, we're wondering how far up and down is our picture. So let's look at range. Okay, range. So we're looking all the way from bottom to top. So the lowest point it ever touches is all the way down here at -5, right? And the highest point it ever gets is right here, which is up at 2. Okay, so these are all the y numbers that we hit. All the way down here from -5, from that point right there, all the way up to 2. That's the highest point ever. So that's all the way from -5 up to 2. So we're going to write -5 is the bottom, less than or equal to y, because we're dealing with the range, less than or equal to 2. And that is our range. So if they give you just dots, then we use these curly braces, right? So curly braces is if they're just dots. If the picture is connected, like it's a smooth curve, then we have to use these inequalities because we have all the numbers in between there. All right, that is functions, domain, and range.